wins and 9 losses. And
Same thing.
exact same thing. Did you just use their numbers? You didn't actually say all right. And from our last group.
30 wins, 40 losses.
Look how much they've been rolling here. 30 and 40. Okay. Let's do some addition. 20 and 18 makes 38, and 40 is 78. Did that without a calculator. This is 19, and 11 is 30, and 30 is 60, and 11 is 71. Now, notice your data wasn't exactly the same. Just like if I gave each one of you a coin and told you to flip it 10 times, in a perfect world, what would you think would happen? In a perfect world, flipping the coin 10 times. 5 heads, 5 tails. But tell me something different you might get that wouldn't surprise you a lot. Instead of 5 heads, 5 tails.
You could get 7 heads and 3 tails.
7 heads, 3 tails. That probably wouldn't surprise you much. Now, it might surprise you if you flipped the coin 10 times and it landed on tails 10 times. You might think there's something wrong with this coin. But just looking at our numbers here, did that come close to what anybody initially predicted that it was? Okay. So what is this fairly close to? About half. It looks like it's about 50-50. All right, so now that you've had the experience that you've had, I want you to think again. What if I gave you 2 additional die to bring your total to 6? Now that you've had the experience that you've had, give me a hypothesis for what you think will be the winning percentage, the winning probability, when you roll 6 die instead of 4. You know that 4 gave you a probability of about a half. About. What do you think 6 will be? All right, and then what I'd like for you to do is I'd like for you and your partner to roll the dice. Let's just go 20 times. Then we'll get some data together. We'll see what we come up with. Make your initial prediction and see how close you go. You're a thinker over here. Now, you think it'll be close to what?
I think it's probably
2.
And that would seem pretty reasonable, wouldn't it?
Yeah.
Okay? So,
2
that's your prediction.
We have 1 lose.
Collect your data now. We'll all come up with a thought. We'll see how that turns out.
Oh, that was
That's a lose.
Supporting your thoughts? No? No? And why is it not supporting your thoughts?
Did you have a sequence of 6? Did you have, or show up that they probably kind of show up 6 once, and so it's almost like you have
So what did you got? I've got 12 to. That's not 20 rolls.
Oh, yeah, it's not too hard. We're not.
12 plus 6 doesn't equal 20. Do two more, just for that.
Woo, look at that one.
All right. All right. Let's see where we are with our second experiment. You all are 11 and 9. So it didn't, yours didn't appear to change. Okay. All right, what was yours? 14.6, okay. And what was your total?
10-10.
10.10. All right, and your total was?
14 and 6.
14 and 6. And Lori, what was your total?
11 and 9.
11 and 9. All right, let's see what happened this second time around. 15, 25, and 15 is 40. This better be 60. 25, 35, and 25 is 60. So notice this was around 50%, a little less than 50% win, and this was right at 60% win. Now, I want you to say to the group kind of what you were saying a while ago about what you thought would happen and what did happen.
So I couldn't come up with a number, but I predicted that it would be greater than 50%, but not as dramatic a change as occurred the first time we added 3 dies to 2.9. So we've added less dies, and the change should be, it should still increase our odds, but it shouldn't be as significant a change, going from 1 to 4.
Okay, so adding a second die increases your chances. Adding a third die would increase your chances, but not as much as from 1 to 2. And then adding another die would increase it even more and more. So in other words, if I let these groups work together and these groups work together, you have all those die, what should it be doing to your chances? Increasing. Could you ever be 100% sure, even if we put all 30 dice out here together, could you ever be 100% sure that you're going to get a 6?
Close.
Mighty close, but not. Now, here's something I want you to talk with your partner about. I want you to think about either the 4-roll or the 6-roll trial. Doesn't make any difference which. I want you to think about what did it take to lose. What had to happen for you to lose? So have a conversation there and be able to respond with what it took to lose.
Probability of winning being 5 and not 6 is much greater. Probability
All right, let's get some responses back from you. Raise your hand if you can articulate to me what it took to lose. What it took to lose. Come on, somebody volunteer. No, I see that hand.
From when I originally thought about the hypothesis, instead of being independent, it was actually dependent on one another, that the first die had to show up as not a 6, so that was 5 out of 6 times that there's an opportunity for it not to reach a 6, and then the next die became dependent to also be 5 out of 6, and then also be at 5 out of 6, and also be 5 out of 6, so that all multiplies because they are dependent on one another.
Now, are you a math major?
Yes.
Okay. Now, for a minute, I want you to be a 10th grader.
Okay.
Okay. I want you to be a 10th grader because I love everything you're saying, but I want you to be a 10th grader now. All right. Tell me in 10th grade language what it took to lose.
All the die had to not be a 6.
Okay. Every single die had to say 1, 2, 3, 4, 5. That's what it took. All right, so if